You know what day it is today? That's right, it's lab day. It's Grignard day. So we're going to do our first reaction. We're going to do a Grignard reaction. And we're going to be reacting bromobenzene with magnesium metal to make phenylmagnesium bromide. That's our Grignard reagent. And then from there, we're going to take that and we're going to react it with benzophenone to make triphenylmethanol. Before we even get started, we have to first dry some glassware. So that's our first stop, is to take a look at the glassware that we need to dry and talk a little bit about the types of joints in these glassware and how the caps and all of that system works on these 1410 joints. All right, I'll see you there in a second. Okay, what we have here on the tabletop is the glassware that is going to need to be dried for this reaction. We have a 25 mil round bottom with a 1410 joint. We have a Claisen, also with 1410 joints. We have the drying tube that we're going to dry and then assemble. We have a 5 mil conical vial that has a 1410 joint on it. And we also have a glass rod here that we're going to use in order to kick the reaction off, but I want this to be dry because this is actually going to go into the chemical reaction itself. So that's got to be dried as well. And I wanted to show these ground glass joints really quickly, that when we look at these ground glass joints, the joint itself, the way that they connect is they simply slide in and they fit inside. So in order to lock this in place though, the type of clamping system that we use are the lids that have a hole in the top of the lid. Now these lids are designed to be used across all these different parts and type of glassware. This piece here is a rubber septum, and the rubber septum has a slippery side and a sort of sticky rubber side. The slippery side is Teflon. That side goes down to point towards any chemicals that may go into the container. And then this lid is applied and screwed on. Okay, so that makes the lid for any of these types of glassware. So that lid is interchangeable and it fits all of the threads that are 1410. It also fits on top of the Claisen, and so we could cap the Claisen if we wanted to. So all of those fit like that. But now, if we take that septa out, the lid is designed to also be a clamping mechanism. And the way that that works is we take it and we put it onto the end of the Claisen, and then once it's on the end of the Claisen, we take and we apply a O-ring. The O-ring slides over. Once it's in place, then the Claisen can be pushed onto the round bottom and then screwed in place, and that holds the whole system together. Now it can't come out. So essentially what's happening is that O-ring is sitting on the top of the ground glass joint and makes it so that the cap cannot come off. Now, we actually don't want this cap on here right now because I'm going to dry this glassware and this piece is plastic and I don't want to damage that piece. So I'm going to have to get that O-ring back out of here, and this is a bit of a poor design on this Claisen because in order to get this O-ring back out, there's not enough room on the glassware itself. See, this piece they made just a little too short in order to be able, you should be able to move the cap up high enough that you could get that O-ring out easily, but instead we needed to use a little bit of a spatula to dig it out with. But okay, mission accomplished. So the oven, normally what we would do is we would let this glassware sit in an oven for 24 hours at about 110, 115 degrees Celsius. That didn't happen. The oven wasn't turned on when we came in today, so the oven is on now, but we're going to do a little bit of flame drying. We're going to flame dry the glassware. It'll get way hotter than 110. We'll take that glassware, we'll put it into a metal container, we'll set it in the oven, and we'll let it cool down to 110. And as it cools down, it will not collect any moisture because it'll be still at 110 degrees. And then we'll pull it out of the oven as we need it. So the next thing we'll show is how we do some flame drying. All right, so flame drying happens over here, over at the Bunsen burner in the fume hood. And you can see we've got the Bunsen burner hooked up, and I've got a striker here. And we're gonna see how talented I am at this one-handed. We'll be zoom all the way out. Turn our gas on. Grab our striker. Hey, not too bad. Okay, next up, drying some glassware. Okay, first up, drying a round bottom. Let's see how this goes. So you can see the glass fog real quick. We don't have to heat it too long. We're just trying to get rid of all of that fogginess that was on the glassware. That should be good. Grab the Claisen. We do the same thing with the Claisen. Grab the drying tube. Just chasing all that moisture off this glassware. Okay, now this is the hard part. These guys, the conical vials, don't like this very much, so we got to be careful that we don't overheat the conical vial. The coefficient of expansion of the glass can sometimes cause the bottom of these conical vials to crack if you overheat them. So we're going a little bit more gently with this guy, and I'm chasing in and out and trying to dry it sort of on all sides. That should be good enough. This one doesn't have to be perfect. It's the other ones that are more important. Okay, into the oven. Get a little bit of a tour of the lab here. Come over to the oven. Get that glassware inside. And we'll give it a little bit of time in there. All right, let's check and see if we can see what the temperature is on this thing. It looks like I'm reading right around 120. It's a little hotter than we like, but it'll be okay. We'll just have to be careful when we actually take that glassware out and we handle it to give it a little bit of time to cool before we try to handle it. All right, next up, we're gonna go set up an apparatus. We're over here at the bench top. And what we're going to do is we're going to set up where we're actually going to do the reaction. We're going to set up the jack stand, the hot plate, the ring stand, the clamps. We're going to set all of that up now. Okay, and I'll talk a little bit about it as I'm doing it. We're going to take the ring stand first. And the ring stand is going to get turned away from me. So I want the ring stand, most people think that the ring stand should always point towards you, but then the base, yes, it's supposed to stabilize this, but it gets in the way. So I always turn it away from me. The jack stand goes in front of it. The hot plate, we'll take the cord, we'll hook the cord into the hot plate. The cord, I like to wrap around the backside, and I like to give it someplace to go where it's not going to cause trouble. So I sometimes will wrap it around some of the fixtures here, just so that the cords don't cause trouble on the bench top where I'm trying to actually work. So those go in place. The clamping system we'll take and we'll put in place. The clamps don't have to go in an exact position just yet. We'll set them when we come back with the glassware that we're going to put in place. And then we kind of get it all set. Now, one really important thing when setting up your clamping system like this and setting up your jack stand. Right now, the jack stand is in its lowest possible position. The jack stand needs to be up. It needs to be 35 to 50% up. Maybe not that high, but at least like 30% up. And the reason that we do that is because we're about to bring out and start clamping up our glassware. If we get all of our glassware clamped up and the jack stand was in its full downwards position, the purpose of the jack stand is to be able to lower the heat and to be able to lower the hot plate so that I can get the round bottom out and without having to move an entire apparatus. So if you start with this in the full downwards position, you got no place left to go. You can't get anything in and out. So we always start it in an elevated position. set up all your glassware, get it all clamped so that it can rest on the hot plate. And then, when all of that is clamped in place, the hot plate can be dropped and things can be moved in and out as we need to. So we'll see as we get that glassware and get it all in place. So our next stop is to get the drying tube and to set up the drying tube. We've got the drying tube out of the oven. With the drying tube out of the oven, we are over here where we're going to set up the drying tube now. Now the drying tube gets set up with a little bit of cotton. We're going to put in the calcium chloride beads. We have our number 1 stopper with a hole in it to affix to the bottom. And I've got a little tamping tool to be able to, it's just a pasture pipette, long stem pasture pipette, in order to get the cotton positioned in the bottom of the drying tube the way that I want it. So the first thing that we do is we just grab a little bit of cotton. And it doesn't take very much. And we don't really want to wad it. We want air to move through this freely. So it's important not to create a wad, but to loosely pack it into the drying tube. So what we'll do is we'll just put it into the top of the drying tube, and then we use the pasture pipette to grab it and move it down into place. When it goes down into place, what we do is we simply tamp it just lightly so that it plugs the hole but still allows air to move in and out. So it's important that we don't over tamp that and create a plug. We don't want a hard plug. We just want a loose plug that is going to keep calcium chloride beads from going through the tip of that. So I think you can see how that just sits inside there. Okay, now the calcium chloride beads. Now, there's a bunch of different ways to get the calcium chloride beads in here. I prefer, just to make it easy, to use my hand. I've got gloves on. I use it like a little funnel. I apply the calcium chloride beads. Let's see where we're at. We're about halfway up. I'm going to go a little bit more. I like it about 3/4 up. That'll work. Maybe a little more than I needed. That'll be okay. And then the next thing that I do is I take that stopper and I just jam the stopper onto the end of this. Not all the way through. And a little bit of twisting in order to get it to go on smoothly. Okay, now it's just going up to that first bump. That means that the glass is only in about that far. That's all it needs to do. It doesn't need to go on there very far. Okay, now this piece is set. We're going to set it in the beaker just as a secondary containment to keep it upright so that the calcium chloride doesn't fall out of it. And we'll get the rest of the glassware out of the oven and start assembling the glass apparatus. I know I said that we were going to get the glassware out of the oven and start assembling, and as I went to do that, I remembered, oh, we need to actually weigh out our magnesium and get our magnesium weighed out, because that's going to go into the dry round bottom, and we don't want to have to open that round bottom again to introduce the magnesium. We want to put it in at the time when the glassware is all hot and being assembled. So we're going to weigh out our magnesium right now, and we're over here at the balance where we can get that done. So one of the first things to understand about weighing and the way that we weigh things out here is that we never just put things directly onto the balance. We always use a piece of weighing paper or a weighing boat. Weighing paper is a lot cheaper. We use a magazine, old catalog magazine paper that is very smooth and slippery that we have cut up in order to make weighing paper. And the best thing to do is to take that weighing paper and to fold it corner to corner, and then do that again so that you make 2 triangles. That causes the paper to then pucker in a way that allows things to sit inside of it so that they don't fall out onto the balance. It's just an easy way to make a little weighing boat. It's quick, fast, and easy. So we're going to get this into the balance. We're going to get the magnesium weighed. We'll get it recorded, and then we'll move on to the glassware. Now, when working at an analytical balance like this, you always work through both doors. We'll take and we'll place our weighing paper onto the balance. we'll go ahead, we'll close the doors. That keeps any air movement out of the balance. We'll tear it. That will zero the balance with the piece of paper in it. Once that tears, has to wait until it stabilizes. Then we can go ahead, we can open the apparatus. We work through the 2 doors again. And what we do is we use a spatula in one hand and the metal or the reagent, whatever it is that we're applying, in the other. We work over the weighing paper so that nothing spills onto the balance. We're at 0.145, actually just a couple more little pieces, and we should be good. Okay, 0.151. Let's close the doors, we'll let it come to equilibrium, and then we'll get the mass. .15164. The little beep indicates that it is stabilized. We'll get that recorded and we'll move on to our glassware. Our glassware has now come out of the oven. We have our glassware sitting back here in the tray, ready to be assembled. We have the other pieces that we need. We have our magnesium, that is our 0.15 grams that we have weighed out. We have a little magnetic spin vane that I have also included in with the magnesium, and this is just a small little, what we call a flea. It's a very tiny spin vane. This spin vane is a little magnet which is coated in Teflon, and that will sit inside the round bottom and will couple to the magnet that is inside the hot plate stirrer, and will stir our reaction through the glassware. So we're going to put that in with the magnesium, and we will add that into the round bottom with the magnesium at the same time. We also have here what is called a rubber septum. And the rubber septum is a very soft piece of rubber that is fairly flexible. It is designed to fit like a cork into the round bottom or into the Claisen, whatever it is that you want to cap with it, and then it folds down over the sides and holds itself in place. So we're going to go ahead and assemble all of that. Hopefully the glassware isn't too hot. We'll see how we do. It's pretty warm still. Okay, so to get the magnesium in, we take and fold the paper and lightly tap and make sure that everything goes into the round bottom. Then what we're going to do is we're going to take the Claisen, we're going to attach the cap first, then the O-ring, slide it down into place. Takes a little bit of pushing it down to get it seated. Sometimes the round bottom will help with that when we seat it onto the round bottom. So we'll give it a little bit of a push. All right, that's screwed on in place. The septum, we want the septum to go on the straight end. So we want to make sure that this goes on the straight end because our needles and our reagents are going to be added through the septa here. And if they're on the curved piece, then the reagents will have to travel the curve and drip down in. This way they'll be able to fall unimpeded down into the glassware, so that's important. This piece goes on, and then like I said, it folds over. So you grab one edge of it and just fold it over. Now, most of the time when we do air-sensitive chemistry, we wire this on, just like with a bread tie, a little piece of copper wire to make that go on. And but that's generally when we're generating pressures within our vessels. This vessel is going to generate no pressure. We don't need to wire that on. It's going to be just fine the way it is. And then the last piece is the drying tube. And the drying tube just fits in snugly. Now it won't stay there, so we've got to be a little bit careful with it as we handle it. We're going to handle it two-handed, but we're going to take it and we're going to put it into the apparatus next. So I'm going to set all of this into that secondary containment while I get it over to the apparatus here and get the camera resituated so that we can see how that all goes together. We're here at the apparatus and we're about to clamp this into place. But before I clamp it into place, there's two ways that I could clamp it. I could clamp it this way with the drying tube on my right, or I could clamp it this way with the drying tube on my left, and it makes a difference. If you are right-handed you are going to be holding needles and things in your right hand to come in and put into the septa. If the drying tube is on your right, the same as your hand that you use, you will have to come around the drying tube to be able to get into the septa. So I want this set with the drying tube on my left so that it's out of my right-handed way. If you are left-handed, then it would be the opposite. The left-handed person would want to have the drying tube on their right to keep it out of the way. So just a little bit of thought in terms of where you want that to go. And as we clamp this into place, I clamp on the claisen, not on the round bottom. Now I'll hold that in place, make sure that it's held snugly, and we will move the other clamp into position. And what we want to do is we want to get it into position in a way that does not create tension in the apparatus. So we don't want to clamp it and force it to go into any position. We would like to take the clamp and allow the clamp to just hold it where it would naturally sit and then snug it up. Okay, now the apparatus is all together, no tension in it, and all set. Let's take a look and see what that looks like. All right, we've got our hot plate that is there. We've got the round bottom. We are clamping on the claisen, not on the round bottom. And we've got the second clamp up here on the drying tube so that the whole thing is held into position. The next thing that we need to do, now that our magnesium and spin vane are in there, we'll bring the hot plate up a little bit. Bring it up into contact. And we like to adjust the hot plate just so that it sits in the middle, if possible. So that the round bottom sits in the middle. That's where the magnetic stirrer is. That will couple to it. And from there, we need to go make a bromobenzene solution.